what is given to us, we have given f to be a real and bounded function, right, on the closed interval AB. And for epsilon positive, I am having a partition P, right? And two arbitrary points SI, TI. These are in this closed interval xi minus 1 xi. These 2 points belongs to this interval, such that it belongs to this such that UP of alpha minus LP of alpha is less than epsilon. This is given to us. So I have to prove this thing. Okay, let's start with the proof. Alright. If you look at this diagram there, this interval, it is xi minus 1 and xi, right? And the two arbitrary points SI and TI, these 2 points belong to this closed interval. We know that small mi is, this is infimum of fx over this closed interval xi minus 1 and xi, right? And capital Mi, this is the supremum of fx over this closed interval xi minus 1 and xi, right? This is a note for you. If any SI TI belongs to this closed interval, then Mi is always less than equal to f of Si, because Mi is the infimum of this bigger interval, and this SI TI, these are the points belonging to this closed interval, right? So small mi is a infimum for this bigger interval, and capital Mi, this will always be greater than equal to f of Ti. Okay, just keep this as your remark or result. Okay, let's start. Let's take capital Mi. I'm defining over here. This is your supremum of fx over xi minus 1 xi closed interval, and this is your infimum of fx over xi minus 1 xi. Now since Si Ti belongs to this closed interval, which means f of Si, the value of f at this Si point, and f of Ti, this will belongs to this closed interval small mi and capital Mi. Fine? Okay, so this is f of Si and f of Ti. Its mod is less than equal to the difference of this, which is capital Mi minus small mi. Obviously it is a positive value, so there is no need of mod, and it is a property that whenever 2 points belongs to this interval, then the mod of their difference is always less than equal to the difference of this endpoints of this interval. For all I is equal to 1, 2, 3 up to n. Now let me multiply delta alpha I, because I need this delta alpha I to be multiplied with this mod. Okay, so let me multiply this f of Si minus f of Ti delta alpha I. This is less than equal to capital Mi minus small mi, and here it is delta alpha I for all I is equal to 1, 2, 3 up to n, as delta alpha I is greater than equal to 0, so sign will not change, okay, because it is greater than equal to 0. So sign will remain same, less than equal to, okay. This implies, now taking the summation all over, because I also need the summation. So summation I going from 1 to n mod of f of Si minus f of Ti delta alpha I is less than equal to summation I going from 1 to n capital Mi minus small mi into delta alpha I. So it is summation I going from 1 to n capital Mi delta alpha I minus summation I going from 1 to n small mi delta alpha I, which is equal to, now this is your UPF alpha and this is your LPF alpha. Yes, sum of all this is UPF alpha. So this is UPF alpha minus LPF alpha, which is given to us, is strictly less than epsilon, which means this whole thing is strictly less than epsilon.